Hello, everybody. Welcome to my mathematical economics series. I'm really happy that you are here. Let me tell you something. Let me tell you something very honestly. I'm not like those teachers who fill the board with heavy words and complicated vocabulary, complicated sentences that even Google struggles to explain. The reason most students watch online lectures is simple. They don't understand that difficult vocabulary. The difficult vocabulary which comes in books or also in college classes. But I'll tell you something important. Mathematics is not hard at all. Yes, what actually makes it look hard are the symbols, terms, and the way it's explained by your professors. Once we break that down in simple language, everything becomes super clear. In this course, I'll teach you every concept step by step using simple examples and easy explanations, whether it's about functions, limits, differentiation, optimization, or equilibrium analysis. We start from basic to advanced. Basic in the sense, I mean arithmetic, algebra, linear equations like that. But in a way that you can actually understand and enjoy these lectures. And at the end of every lecture, I'll also discuss ample practice questions. I mean, many practice questions. So that you don't just watch, but also learn by following. And if you want to test yourself, I'll add a link to a topic wise test in the video description. My goal is to make you say, hey, this isn't difficult at all. I'll make you say mathematical economics isn't difficult. Because trust me, once you get comfortable with the math behind economics, the economic subject becomes 10 times more interesting. So I suggest you to grab your notebook. That would be really helpful if you write what I'm teaching. And let's learn mathematical economics the easy and smart way, without fear, without confusion, and without any complex words. So in this introduction lecture, I'm not going to teach you any class, but I'm going to explain what topics that I'm going to teach and how I'm going to teach. So this course is divided into 5 parts. I mean, it has 5 modules. And in the first module, I'm going to talk about pre-calculus. So in the first module, we're going to talk about pre-calculus. Pre-calculus is nothing but some basic mathematical concepts which are useful for single variable and multivariable calculus. So, and this single variable calculus is also called as calculus 1 and calculus 2. And this multivariable calculus is called calculus 3. So after completing pre-calculus, I'll move towards single variable calculus and then multivariable calculus and then sequences and series and matrix algebra. So what topics that I'm going to teach in pre-calculus? I'm going to teach arithmetic, algebra, and then systems of linear equations, and next quadratics and polynomials, and then exponential and logarithmic functions. So I'm going to tell you what I'm teaching in arithmetic right now. In arithmetic, the first lecture will be about order of operations. Order of operations is nothing but the board mass technique that you must have studied in your school, which means bracket, orders and operation, division, multiplication, in addition, subtraction. And then I'm going to talk about fractions. You must know this. Fractions are nothing but numbers in p by t form. And we're going to talk about how to add these fractions like a plus b, a by b plus c by b equal to a plus c by b. In this fractions lecture, I'm going to discuss all these formulas. Don't worry if you don't know any of this. I'm going to explain all of this in detail. Right. After completing fractions, I'll move towards teaching percentages. So this might seem funny to you because you must have studied in 10th and in which you have studied mathematics, and also you must have studied mathematics in your bachelor's as well. But understanding basics is really important. If your basics are strong, your concept is strong, then you're going to learn advanced topics much easier. And trust me, learning basics is very hard than learning advanced topics. So in percentages, yeah, we're going to talk about questions of this type. X percentage is equal to x by 100, which means 16% is equal to 16 by 100, right? I'll explain all of these in detail. And after teaching percentages, these power functions, power and exponents. So that's what we're going to cover in the arithmetic portion. After that, we have algebra. So in algebra, I'm going to cover some interesting topics. So in algebra, the first lecture is about solving equations. We're going to solve some basic equations like x plus 3 is equal to 5, finding x, 2 plus y equal to y, 1 minus 3 equal to 6. We're going to find this variables here. And then the second lecture will be about expanding brackets, which will be in the form of c multiplied by x plus y is equal to cx plus cy. So on. There are around 6 or 7 types in expanding brackets. I'll explain all of them. And in inequalities, which is the third lecture, we will learn how to solve and manipulate inequalities and how to express solutions in interval notation. Inequalities means which are not equal. It's simple as that. So here, this one is equal to this one. Left hand side is equal to right hand side. But here, the equality is not happening. Like, you're going to solve all this in the lecture when you're going to learn, right? So after completing algebra, I'll move to teach systems of linear equations. So in systems of linear equations, I'm going to teach linear relationships and their graphs. And we learn how to solve linear systems by substitution and by Gaussian elimination. You might not know what this means, but we're going to discuss in detail while I'm teaching. And linear relationship, linear functions will look like ax is equal to k or ax plus dy, which is equal to k, which is linear, right? And after this systems of linear equations, we talk about quadratics and polynomials. With quadratics and polynomials, I'm going to discuss these 4 topics. The first one was solving quadratics by factorization method. Plus a multiplied by x plus b is equal to x squared plus a plus b x plus ab. B multiplied by x minus d x minus c, which is equal to 0, such that x is equal to d or x is equal to v. These kind of formula that I'm going to teach. So after that, we're going to talk about exponential and log functions. So that's the end of topics in algebra. So after completing all of this, we'll go to single variable calculus. So in single variable calculus, we're going to have 5 modules. The first one is functions and inverse functions, and the second one is definition of derivatives. I'll teach the basics of derivatives, and I'll teach rules of differentiation, and then we'll move towards knowing about slope, curvature, and optimization. We'll talk about integrals, the basics of integrals. So let me tell you in detail what I'm going to teach. So the first lecture will be about functions introduction. And the second lecture will be about inverse functions. In the third lecture, I'm going to explain economics applications. So here I'm going to use a demand function, an inverse demand function. For that, we're going to talk about how much a good is determined in a market will depend on its price, right? The relationship between quantity demanded and the price of the good described by this demand function. We'll talk about this, and then derivatives. I'll talk about notions. I'll talk about notions and notations of derivative. After that, we're going to talk about derivations. After that, we're going to talk about some basic definition of derivatives like H. So after that, we're going to talk about non-differentiability, and then you're going to talk about some economic applications. Uh, in economics, you will encounter the word marginal, and this will always mean a derivative. So we're going to discuss about that. I'm going to talk about the power rule, which is d by dx x power n is equal to nx power n minus 1. And after talking about the power rule, I talk about natural, exponential, and logarithm. After that, I'm going to talk about the sum rule, and then the product rule, the quotient rule, and the chain rule too. So let me write these basic formulas here. I'm writing this just for your reference. We won't talk more than that. After that, we're going to talk about the chain rule and then how combining differentiation works. Like how do we differentiate more complicated functions by combining the rules about all of this. So after that, we're going to talk about slope, curvature, and optimization. So the first one will be the monotonicity, which is increasing and decreasing. We're going to talk about tangents and normals. So if this is a graph, in this point, if you draw a line, then this is called a tangent. So we're going to talk about this curvature, which is convexity and concavity. Convex graphs looks like this, upward sloping. So all of these graphs here, this one, also this one, these are all convex in nature, and I'll show you some concave functions too. We're going to talk about what types of functions give this kind of weird graphs, right? This is concave, and this is also concave, and these are opposite to the one that I've shown you before. So after this, we're going to talk about finding stationary points. For it, I'm going to talk about the first order condition, and then I'm going to talk about classifying stationary points, which means finding local minimum and local maximum. So at a stationary point, if f double prime is greater than 0, then it is local minimum. If it is greater, if it is less than 0, then it is local maximum. I'm going to discuss all of this. And then I'm going to talk about optimization. And then I'm going to talk some economics application. I'm going to talk about economies of scale, profit maximization, slope, and curvature of production function. And we also solve some many questions after each lecture that I'm going to teach. Here I'm going to talk some basics of integrals and then computing indefinite integrals as antiderivatives. And then I'm going to talk about definite integrals. After computing indefinite, I'm going to talk about definite integrals and fundamental theorem of calculus. And then I'm going to talk about economic application of consumer surplus, which is linked to integrals, of course. I'm expecting that you don't know any of this, but I'm teaching that. But I'm telling you that what I'm going to teach in this series. So after that, we'll move towards multivariable calculus. In multivariable calculus, the first topic would be partial differentiation. And after completing partial, I'm sorry, this is not partial differentiation, which should be named as derivatives. Doesn't matter, but partial derivatives. And after completing partial derivatives, I will focus on implicit differentiation. So I'll focus on functions of several variables. And then first order partial derivatives. And then I'll move towards teaching higher order partial derivatives. After that, I'm going to teach some economic applications in production function, isoquants, and marginal products. That's the end of partial derivatives. And then in implicit differentiation, in this implicit differentiation, I'm going to talk about just the basics of implicit differentiation. It will be a 30 minutes lecture. After that, I'm going to talk about economics application. In economic application, here I will introduce you to the concepts of utility functions, indifference curves, and the marginal rates of substitution. After that, we'll move towards sequences and series. I will teach you introduction of sequence and series. You must have studied them in your school. Sequences, in sequences, I'll teach notation and terminology. I'll write it here. Notation and end terms. You go right, and then arithmetic progressions. Arithmetic, and then geometric progressions. And after that, I'm going to talk about econ application. Again, here we're going to talk about GDP growth. So, in series, we're going to talk about, in series, I'm going to talk about sums, series, and sigma summation notation. This sigma looks like this. You must have seen this in QIQs. We're going to talk about this. So, and then in the same, we're going to talk about arithmetic series and geometric series. And in economic applications, I'm going to talk about discounting and bond raising. That's the end of sequences and series. We'll move directly to matrices. This is actually really easy. It actually looks like this. Those who don't know matrices find it really hard, but if you just watch the 20-30 minutes lectures about matrices, you will just find it really easy. So here I'm going to talk about matrix terminology and notation. And then I'm going to talk about matrix addition, how two matrices are added, and scalar multiplication. Scalar multiplication are component wise, and I'm going to explain all of this in detail in the following lectures. And then we'll talk about matrix multiplication. After that, we'll talk about economic applications in labor market. That's not the end of matrices. So after this, we're going to talk about determinants and inverses of a matrix. This is another module, determinants and inverse. So in determinants and inverse, the first lecture will be about determinant of 2 into 2 matrix. 3-2 matrix is nothing but a matrix which looks like this, horizontally 2 and vertically 2. So after that, I'm going to talk about inverse of a 2 into 2 matrix. And then we're going to talk about economic application, which is about labor market transitions. After that, I'm going to talk about matrices and simultaneous linear equations. Matrices and simultaneous linear equations. Right. In this module, the first lecture will be about encoding systems. Encoding systems into matrix equations. And then I'm going to move towards solving simultaneous linear equations using matrices. So after that, we're going to talk about some systems of linear equations and matrices and their applications in economics. And that will be the end of this lecture series. So after this, the next lecture that I'm going to upload is from arithmetic, as I told you. The first one in pre-calculus, I'll start with teaching arithmetic. So there will be 4 lectures from arithmetic. Duration will be from 30 to 40 minutes. That's it. And algebra 4 lectures, systems of linear equations 3 to 4 lectures, and quadratics and polynomials 5 lectures, and exponential logarithms 4 lectures. And then we'll move towards single variable calculus. There are 5 modules here, and then multivariable calculus 2 modules, and then sequences and series, which are really easy, and then matrices extremely easy. Thank you so much, guys. Bye.